a table to solve rather than direct solving.
Right.
Okay. And a lot of students really like this approach because direct solving can take way too much time. Um, to do this method, it's pretty straightforward. You use the answers because they typically they'll give you X or Y, and then you use it to build the other variable, or they give you Y or X, they give you X to find Y or Y to find X kind of thing. Um, and so you build this table and then you check your answers. However, this only applies to multiple choice questions, so it doesn't work for everything. But it's a pretty good approach. So um, I'll do a couple of examples and then get you involved in solving it. So students really like this. Um, the so the idea here is that they're asking you for the value of X. So the table starts out by these are all the X values. And the Y values, you go to one equation or the other. So you pick whichever equation is easier. In this case, the first equation is easier. I think that's pretty reasonable. You have to figure out what the Y value is. And it's like, okay, well, if X is 6, X plus Y gets you to 21. So Y is 15. If X is 8, Y is 13, 8, and 6. So you build this table of ordered pairs, 6 comma 15, 8 comma 13, 13 comma 8, 15 comma 6, and you try these in the second. Now it's your choice how you try them. You can try them in order. You can try to deduce something from it. Um, it's kind of up to you at this point. So um, when you try them, you obviously got to figure out, make sure you do it correctly and figure out if they equal -3. But the idea is here is you're never actually going to solve the system of equations. And this will save you time that you don't have. All right. So let's just say we start with the first order pair, 6, 15. Is 6 minus 2 times 15, does that equal -3? Yes or no? This question to you. Does that equal -3?
Um, no.
It does not. We move on to the next one. Is 8 minus 2 times 13, does that equal -3? Again, I'm just using these ordered pairs, these XY pairs into this equation.
Uh, no.
The results does not work. Okay. So you might be thinking, oh boy, the method is no good. 13 minus 2 times 8, does this equal -3?
He, yeah.
Which one does? So there's your answer. So I found that most students prefer to try the answers, which is okay. You're better off trying the answers when you know that you're converging on the right answer, which you are in this case by building this table. All right. So let's look at another example here. All right. If xy satisfies the given system of equations, what is the value of y? So this time they're giving you the values of y. You need to find x. Now it's telling you in the first equation that y is x plus 2. So to get x, you might have to rewrite this equation. X is really y minus 2. You take each of the y values and subtract 2. So we got 0, 1, 2, and 3. Now we're used to it being x comma y, x then y. So I would actually rewrite all the y's and then cross this out. So now we're looking at the ordered pair 0, comma 2, 1, comma 3, 2, comma 4, and 3 comma 5. You're going to try these in now the second equation. And you're going to see which one works. So I'd like you to do that. And you can start from the first, the bottom, the middle, whatever you want, but try these and tell me which one is the right answer.
Zero and two.
The letter A. Very good.
Great job, buddy.
Right. So now let's look at another example. We got this example and one more before I'm going to have you be more actively involved. So it says which in the solution to system of equations above, which of the following is the value of x? So they're giving you the x's. These are x's.
Oh,
Now,
okay.
in your opinion, which equation is easier to solve for y? The first one or the second one?
The second one.
Yeah, just slightly. So you do have to solve for y, which could be, could be kind of a pain, but um, what I would do, and this is a little bit awkward, is I would actually move the 10y right and subtract the 16. So this becomes x minus 16 equals 10y. Divide by 10, divide by 10. So your y values are x minus 16 divided by 10. So you have to take this x value, subtract 16 and divide by 10. So at first glance, it doesn't look great, but division by 10 isn't as bad. It's either a decimal or a whole number. So like, for example, minus 14 minus 16 divided by 10, what does that become?
Negative two.
Close. Give that one more look. You get it's negative 30 over 10.
Oh, negative three.
Negative 3. Now, negative 4 minus 16 over 10, that's the one that's negative 2.
Oh, okay.
Tell me what the last one becomes.
Um, eight.
You're subtracting, you're putting this 16 over here on the right. 16 minus 16 divided by
Oh,
10.
zero.
0. And then B is minus 12 minus 16 over 10, which is minus, minus 16, minus 28 over 10, which is minus 2.8. Okay.
Oh.
All right. So now the the next thing here is you're going to go to equation number 1 and you're going to try these ordered pairs. Now, which is the easiest to try of these ordered pairs? Or which is the hardest?
Artist, probably B.
Yeah, so maybe do that one last. What do you think is the easiest or
C.
easier? Easy, maybe the easiest.
C.
I would say then C, and then maybe A is medium. So like there's always an order to try these things and like you don't just arbitrary. Let's try D, C, A, and then if it's neither of those, then it's B. You're gonna try them in the minus 3x minus 4y equals 20. Go ahead and try D and C and A. Let me know if any of those work, please.
think it's the
Did you say a D like dog or
no
C like
C.
car?
C
D.
like cat.
Let's take a look here. Is -3 times -4 minus 4 times -2? Does that equal 20? Sure does. 12
Yeah.
plus 8 is 20. Good. Okay. All right. So like I said, sometimes these are applied to story problems. Okay. So it says last week, if Raul worked 11 more hours than Angelica, if they worked a combined total of 59 hours, how many hours did Angelica work last week? So these are the hours for Angelica. Raul worked 11 more, so plus 11, which means you add 11 to each of these numbers here. And then what are we looking for here? What did it say in sentence 2 there?
How many hours did Angelica work last week?
Well, no, that's those
Oh,
are the answers, but what's the other equation? Like we know that Raul worked 11 more. That's how we came up with the second part of the table. What's the other constraint here?
oh, it's A.
Right. It's the combined total of 59
Yeah, it's
hours.
adding.
So you could create a total column as well. So it's not just writing down the answers, you could add them up. Um, depending on what your, goal is here. So, I mean, this is just a strategy, right? It's one of many. Like we saw in the previous problem, like it's really paired with another one, which is okay. I'm going to be smart about how I try the answers, not just going to try them in order and think through it. But the class today is designed for you to make a table. Okay. So in an effort to get you to make the table, because I've had students try to not use this approach, I'm going to, for the first few examples, give you the answers and give you the equation to use to build the other part of the table. So, um, all right. So to start here, this is the value of y. Okay. And x is 6y. So I want you to give me the values that go over here. And you're allowed to use a calculator. No problem with that. But give me those x values, please.
Uh, oh, 12, 24, 48.
Try again.
Uh,
You are allowed to use a calculator. Please.
okay. 72
Okay.
and 144.
Okay. Now, what did I recommend doing when it's y then x?
Adding the total up on side.
Actually, putting them in order, x then y. So
Oh,
rewriting and crossing out. We're just used to things being in x then y. Okay. So here is the other equation. All right. So I want you to tell me which one of these ordered pairs works in the second equation.
uh, B?
You said D like dog?
No, B, I
B.
think.
Okay. So we have y is 4. So 4 times 4 plus 1, does that equal 24? 4 plus 1 is 5. 4 times 5 is so that one's out.
A.
It is A. Very good. Okay, so let's look at the next one here. Same idea. I really, really want you to build the table first. All right, so here is the table. And this is for X. Y in our problem is going to be 0.5x minus 10. At first, you might say, it's a decimal, but 0.5 means to cut in half. You're just cutting these numbers in half and then subtracting 10. So give me the y values, please, whenever you have them.
-10.
Oh, try again. What is half of -2? Again,
-1.
yeah, -1 minus 10. -1 minus 10.
-11.
Okay.
9.
Try again. The sign is very important.
-9.
-9, yeah. Okay, keep going.
8 or -8.
Nope. You're taking
8.
half of 18. Half of
Yeah.
18 is,
-1.
yeah, -1. Good.
Um, -8.
Try again.
8.
How are you doing all of these? Are you using the calculator or doing them by hand?
I'm using a calculator.
Okay. Do you need some help on using the calculator because you got every one of them wrong? And I'm only saying that because this is not the hard part of the problem, and we got to get
It's
this right.
8.
Are you actually entering 0.5 times -2 minus 10, or are you doing like 0.5 times -2, enter?
Oh, bruh.
Like, I don't know. I'm asking, what are you doing
I,
to
I
answer?
wasn't multiplying it by -2.
Okay. Well, you
18.
get some more chance at this. The equation that you're now solving is, let me snip this in, is right here. So they're already in the right order. You got X and then Y. Which of these is the correct answer?
Um, dang. C.
Very good. Okay. So we've done enough problems here where I've sort of made the point that this is a good approach. You can solve the next one however you want. Okay. I recommend using the table method. This is the value of y. If you want to find x, I would use the first equation to build your table. You do have to solve that equation for x, but that's not too bad. But I will leave it to you to work through this now that you know how to work it out.
Um, B.
Okay, you said D.
Yeah.
Give me your table if you did make one.
Uh, I didn't make one.
Okay. How did you solve it then?
Like substitution.
Okay. All right. So it's recommended that you try this approach. So now I'm going to give you one where you really have to use this approach. D is correct. By the way, good job on that. Um, this one is much harder. You can use substitution, but it's way more difficult. So I'm going to suggest you use the table method for this. They're giving you y's this time. So go ahead and give that a try, please. All right, so we're about 2 minutes into this. Do you need any help setting up the table or have any questions about this one?
Uh, yeah.
Okay, have you found any of the X values for this table?
Um, for what's it called? Are A and B 3 and 4?
The X value here for A?
Yeah,
What is the second? I assume you use the second equation for it. Is the second equation solved for Y? I'm sorry, for X. Is it solved for X?
yeah.
It says the X value is Y plus 1.
Or -3.
Okay, -3. And what's the next one for B?
-1.
Okay, and for C?
3
And the
and
last one?
5.
Okay, so now you have to use the first equation. Which is the easiest X values to try in that equation out of these -3, -1, 3, and 5, do you think?
Probably the positive ones.
Okay, so either C or D. So did you try 3 or 5 in this first equation?
Um,
If not, I would do that now.
yeah. 'Is it C?
Is C. Good. Okay, let's try another one here. We'll do one or two more, and then we're going to switch to another topic. But you're going to get something on systems, so you might as well do this. So, all right. You can solve this one however you want. You do not have to use the table method, but go ahead and give this a try, please.
0.
That's your final answer, 0.
Yeah.
Yes. It's very good. All right. So this, let's do. All right, this is a story problem where you can use the table if you would like. You do not have to. Here is either our last or second to last one of these.
Um, 15.
It is 15. Good. All right. One more story problem, and then we'll move on to a math subject content area.
Um, 3.
Double check here. Yes, it is 3. All right, good job on that. Kind of up to you how you want to proceed on these types of problems here. So we're going to look at just kind of a related topic. It's kind of a system, kind of related to systems here, but um, do you remember uh, what the difference is between parallel and perpendicular?
Yeah, I think.
Could you tell me about one or the other, or give me any information about them?
Uh, well, like parallel is like right across, like I don't know, it'd be like the two lines like in the street, and
So think about slope now. Tell me if you remember anything about slopes for parallel and perpendicular lines.
well, they'd be the same if they're parallel.
Okay, same slope. What do you remember about perpendicular, if anything?
It's like two lines like intersect like um at a right angle, then they're like perpendicular.
Okay, so that right angle, that's important.
And
All right,
they intersect when parallel lines don't.
okay, so are these two equations parallel or perpendicular?
Uh,
And what I'm really asking is what's the slope of the first one? What's the slope of the second one?
First one is it goes down 7, right? Or to
The slope is the number in front of x.
so y. Yeah, it goes down 7.
The slope is the number in front of x. Like in math, we think of in front of as being to the left of.
Yeah, 7/1.
I don't know how much more clear I can be. The number
It
in front of
goes
x
through the
is
it
to the
goes
left
through
of x.
7, negative
Left,
7,
left of x. Which number is to the left of x?
5.
I'm using an arrow to point at it. Yeah, 5. Okay, so that's the slope. The slope is the number in front of x. How about in this equation here? Second equation, what's the slope?
1.
Really? I mean, it said like 5 times it's the number in front of x,
Yeah, that's what I said.
but there's not. There's a 5 in front of the x. I mean, are you able to
That's
see
what
my
I just
screen
said.
currently?
That's what I just said. What you're pointing at is exactly what I just said.
You said 1 and you said 1 and then I asked you why you didn't tell me 5, but it is 5. It's the number in front
That's
of
what
x.
I said. 5.
Okay. Okay. Try to give me a good effort here for the last 10 minutes, please. You're doing great. And these are not trying to be difficult here. Just give me a good effort for the last little bit. Y equals 1/2 x plus 3. The slope of this equation is 1/5. The number in front of x to the left of x, it's everything. If it's a fraction, it's everything. It could also be a decimal. The slope here is 0.5. It's the number in front of x to the left of x, which also happens to be 1/2. It could also be that it's written this way, x divided by 2. And really, there's really a 1 up here, as you know. The slope here is 1/2. Okay, so take a look at these three examples and really make sure you understand how they could appear and they're all the same. You know, we got a fraction, a decimal, fraction where we don't have the number written, but it's still that. Is it clear that the slopes are all 1/2 or why they're all 1/2 here?
Yeah.
Great. So now let's look at an example here. Let's say it's y equals 2x over 5 minus 1 and y equals 0.4x plus 3. Can you give me the slope of each of these, please?
Two over five. And um 0.4.
Now, are these the same? And before you answer, always be sure that, you know, you're allowed to use a calculator, like either convert one to a fraction or one to a decimal and then confirm with a calculator if you need to.
Yeah.
Yes, these are the same. So these are parallel lines. Is that okay so far?
Yeah.
All right. We'll get the perpendicular in a moment, but we're going to first just do some parallel. They're the easier of the two to see. So let me grab a question or two. All right. So all right, so unfortunately, they're not all as basic as what I just showed you here. They require a little bit of effort. Could you tell me the slope of the given line, please?
Um
The
oh,
given line is yeah,
-3.
-3. Okay, good. Now, none of these other equations are in the right form. Now, if you didn't notice, I'll explain it now. All of these were already solved for y, which meant you could just read off the slope. Here, none of these are solved for y. So I'm gonna take the last one here and I'm gonna solve it for y. Okay, so to do that, I'm gonna subtract x from both sides. When you subtract x, you want to put it in the front. 3y equals -x plus 1. Divide by 3, divide by 3, divide by 3, divide everything by 3. It's really a -1 there in front of the x, so it's -1/3 x plus 1/3. The slope of this is -1/3. It's the number in front of x, but you can only get that if you solve for y, okay? Which is obviously not the same as this, okay? So D is out. So I'd like you to pick another equation here, doesn't matter which one, and solve it for y. And then we'll see if it's the right one. So pick one, doesn't matter, just solve for y and let me know what you come up with.
Uh, A is 15/2.
So for A, let's look at A here. So we have 6x plus 2y equals 15. You first subtract the 6x from both sides of the equation. And then you really want to put that in front. So it's 2y equals minus 6x plus 15. Do you have something like that written down? It's okay if you don't. You can get caught up here. Because you said 15/2, which is correct. You do end up dividing by 2. But the slope is the number in front of x. This ends up being minus 3x plus 15/2. What is the slope of this equation here?